Alright guys, so these are notes on exponential applications. Um, Before I get started with this, I just have a little note for you. Seriously, turn your music off, make sure that you are listening to the explanations of this. Otherwise, there's no point in me making a video on it. Okay, so turn off the music. Alright, so each year the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So first you need to define your variables. What is your input? What is your output? Okay? So X should be the number of rounds playing, and Y should be the number of participants that you have left, because you're going to input which round you're at, and you're going to get an output of how many participants are playing. Okay? With the exponential equation, we're going to do that Y equals A times B to the X power. So you need A, which is your initial value, your starting value, and that would be this 128 participants. Okay? And then if half of them are eliminated every time, then you're multiplying by half. And 1/2 is 0.5. You could leave this as a fraction if you wanted to, as 0.5. That would be perfectly fine. Okay? So this is your equation. Keep in mind that when they ask for the equation, you need to keep Y as Y and you need to keep X as X. Okay? If you're not sure about what X and Y are, something that you can use to your advantage, if you can identify this initial value, that's the first output. So since it says play starts with 128 participants, that tells you right here that is your Y value, is the number of participants. Okay, so just kind of a little clue to help you out. And then we need to find out what happens after 5 rounds. Rounds is our input, so we're going to put a 5 in for this exponent, which should get us 4 players. Okay? And you need to make sure that you can wrap this up, put a little bow on top of it, and give it to me in a sentence. What does this number 4 mean? Okay? So you have, after 5 rounds, there will be 4 participants left. And of course, there's a couple different ways you could state that. Okay? But that is what we are looking for. Okay? Alright. Next problem. You open a bank account with $500. You get 3% interest every month. Find out how much money you have in your account after 1 year. So since the starting value here is $500, that lets you know that your Y is going to be the money in your bank account, and then your X is months. Okay? So time in months, please make sure that you write this in months part. That's super important. The more specific you are with these, the easier it's going to be to answer these questions. Okay? And then you've got to think to yourself, is this growth or decay? And since you're earning interest every month, you have to think this is growth. Alright? And since it's growth, I should be multiplying by something that is greater than 1. So my B value should be greater than 1. Okay? And the shortcut here is to add 1 to the percentage that you're looking at. So since we're looking at 3%, okay, you need to keep in mind that 3% means 3 per 100. So you need to make sure that you divide that and get your 0.03. Alright? And you're going to take this value and you're actually going to add it to 1. So my starting value is 500, and then I'm going to do 1 plus my 3%, because I want everything that I already had. I want that total from before, and since it was my total, it was all 100%, and I want an additional 3% after that month. So I have 103%. And you can actually give me either one of these answers. If you left it like this, it would be marked correct. And if you added them together, it would be marked correct. So just kind of a nice little notation for yourself, okay? And then it's asking me what's happening after 1 year. This is where you need to be careful. Do not put 1 in for X. X is in months. So you have to think about how many months are in a year. Hopefully, dear Lord, I hope you know that it's 12. So when you substitute 12 into here, you should get $712.88. Please make sure that you are holding one of those blue calculators, you are actually typing this into the calculator so you know how to, and you're getting the correct value out. Okay, you do not want the quiz to be the first time that you do that. Okay, and to get up to this exponent here, just in case you aren't sure, in your calculator, you're going to type 500 parentheses 1.03, and then that caret up with the 12. Okay, so just something to keep in mind. That is what you are going to have to put into your calculator to get this answer. So make sure that you're actually practicing that skill. Okay? You don't want to have to think about it during the test. It should just be a natural thing to click those buttons. And then again, you want to put a nice little bow on this and give it a sentence. So what does this mean? And this means that after 1 year, you will have $712.88 in your account. And so 2 decimal places make sense here because we're talking about money. Okay? You need to make sure this is a real-world problem. You have a real-world answer. Okay? All right. Next one. If a tray of water is put into a freezer, its temperature will begin to decrease. So right away, you need to know that this is decay. Okay? Because it's decreasing. If it starts out at room temperature, 65 degrees, there you go, that's your initial, so you know that your Y value here is going to be temperature in degrees Fahrenheit, and loses 20% of its heat every minute. So instead of doing that 1 plus, we are going to do 1 minus. This means 1 minus because it's decay. Okay? And what we are going to subtract here is that percentage. So again, we have 20%. That means 20 out of 100. So you should get 0.2. If you want to put 0.20, because that makes a little bit more sense in your head, that's perfectly fine. Okay? So you're going to do 1 minus 0.20. Okay? That is what you are multiplying by every time. Because you want your equation to state how much of the temperature it's maintaining, not how much it's losing. Okay, so first of all, our variables, x is going to be time in minutes, because it says minutes right here. And y is going to be temperature in degrees Fahrenheit. Okay? And then your starting value is 65, and you're multiplying by 1 minus 0.20. So you're multiplying by, it's maintaining 80% of its heat every minute. Okay? And you know it's going to decay because this number you're multiplying by is between 0 and 1. Okay? And then I want to know what happens in half an hour. So half an hour is how many minutes? 30. So we substitute 30 in, and you should get that it's 0.08. And what does that mean? It means it's 0.08 degrees Fahrenheit. All right? All right, so after half an hour, there will be, that's actually, let's maybe just for funsies spell that correctly. What do we think? There. Half an hour, the water will be 0.08. Sorry, I got interrupted in the middle of that. Lost track. Okay, so that's your final answer. All right, next problem. So, you are going to see problems that look like this. You might be given a table. So, the populations of rabbits have increased from 1950 to 2000, as the data in the following table shows. So, when you define your variables, especially for a table, this is the absolute most important, really one to be specific about. So, and when we did our activity in groups, you guys did a really nice job of going through with this. So when you define your variables here, your input and your output are already here. So you know that x is going to be years, but it's not just going to be years. What's happening with the years in this table? First of all, you're starting at 1950. It even tells you that here. Okay, so years since 1950. And you're not counting by ones here, right? These guys are counting by every 10 years. So in your variables, your x value is every 10 years since 1950. being this specific is really important because there's different ways to write the equation to kind of slide it back and forth here. So you need to make sure that you are very, very careful with this, okay? And then your population of rabbits, it is rabbits, it's not people, so make sure you have that. And it is in thousands, and you will see how that affects our answers a little bit, so that's very, very important to know. So this is not 1.4 rabbits, this is 1.4 thousand rabbits, okay? So there's that. Then we need to discover what our equation is going to be. So we have our starting value of 1.4, which is awesome, and you need to figure out what are you multiplying by each year, what's happening to these numbers. Hopefully you can see that they're doubling, right? So if they're doubling, you are multiplying by 2. So I start with 1.4, I'm doubling it every 10 years since 1950, okay? So, how do we predict the population in 2045? I know a bunch of you guys already know this. We're going to take 2045. We are going to subtract 1950. And from that, you should get, unclick, you should get 95. But 95 is not what we're putting into our equation because it's every 10 years. So how many 10 years is 95? Well, you need to divide that 95 by 10, which will give you 9.5. Okay, so that's where this equation is coming from. So 1.4 times 2 to the 9.5 decades. And if you wanted to put decades here, that would work also. And we are going to take a little care and consideration with this piece as well. I'm going to show you how we take our final answer from these two and pop them here as well. But let's keep going with this. Use your equation to predict the population of 1940. So we're at 1950, and we're going backwards 10 years. So what does that make our exponent? Well, it makes it a -1. Okay, because we're going backwards in time. So you should get 0.700. Okay? The last piece to this that we need to take care of is since our population is in thousands, we need to take these final answers here and we need to multiply them by 1,000, which is going to give you these as final answers. So multiplying by 1,000 will take your decimal and scoot it over 3 spots. So instead of 1,013.708, you're going to have 1,013,708 rabbits. And instead of 0.7, you're going to have 700 rabbits. Okay? So a couple things to take in mind. Just, keep it in your brain. Work through the problems in the packet. If number 2 in particular throws you off, make sure that you're writing out questions and we will go over them next class. You are welcome to come in and see me tomorrow, even though it is not a B day. All right? Be good.